In exercise 3, we are going to look at the factoring z2 adjoint x mod a, where a is the principal ideal generated by x cubed plus x plus 1. And before we start to fill in the Cayley table right here, that is already started for us, and there are only 9 entries that we need to fill in. Before we do that, let's look at how elements in this ring behave. So let me change colors. So in general, what are some relationships that we can use in this ring when we are doing these coset computations? So in the ring R, we have that x cubed plus x plus 1 behaves like 0. So x cubed plus x plus 1 in coset calculations behaves like 0. And so we can use that, let's say, so we have x cubed plus x plus 1 is equal to 0. And so notice that this implies that x cubed behaves like minus x minus 1. So every time we see an x cubed, we can replace it with minus x minus 1. But the coefficients of our polynomials in this ring are only 0 and 1. So minus 1 is actually the same as 1. So this is the same as x plus 1. So every time we see an x cubed, we can replace it with x plus 1. And every time we see an x to the 4th, we can do something with that too, because x to the 4th is equal to x times x cubed. But we just said that we can replace that x cubed with x plus 1. So if we do that, we have x times x plus 1. So that means we can replace x to the 4th with x squared plus x, or x plus x squared, whichever you like. And so you can imagine that any power higher than an x squared term we can somehow replace. So an x cubed we can replace with x plus 1, x to the 4th we can replace with x plus x squared. And so we can do that, we can use that to reduce any polynomial to something that is just quadratic. Okay, so this is very useful. Let's use these observations to fill in some of the missing entries in our Cayley table, in our multiplication table right here, in our multiplication table. So let's see, we have x squared plus a times x squared plus a. That gives us an x to the 4th plus a, but we just said x to the 4th is the same as x plus x squared. So this gives us an x plus x squared plus a. So we can fill that in here in this first entry. Okay, next one over in this row is x squared plus a times 1 plus x plus a. That is x squared plus x cubed plus a. But the x cubed we can replace with an x plus x squared. So we're getting this right there. Oh, I'm sorry. I made a typo. I replaced the wrong thing. X cubed is x plus 1. There we are. So we get x squared plus x plus 1 plus a as our next entry. That's x squared plus x plus 1 plus a. Quite a bit going on there. Okay, let's do one more. So what if we take x squared plus a times x plus x squared plus a? That gives us an x cubed plus an x to the 4th plus a. But the x cubed we can replace again with an x plus 1, and the x to the 4th we can replace with an x plus x squared. So we have this, but you see that's going to reduce further because x plus x is 2x, but 2 is the same as 0 because we are mod 2 in this ring. So the only thing that's left over is a 1 plus x squared plus a. So we can fill that in. And so in this manner, we can fill in all the other entries as well. We get x squared plus x plus 1 plus a in this entry. We have 1 plus x squared plus a in this entry, because multiplication is going to be commutative in this ring. And then what's next? So we have 1 plus x plus a times 1 plus x plus a. That is 1 plus x plus another x plus an x squared plus a. But again, x plus x is 0. So this is 1 plus x squared plus a. And the next one, 1 plus x plus a times x plus x squared plus a. That is an x plus an x squared plus an x squared plus an x cubed plus a. But that is, well, the x squared plus x squared, that's going to go away. We are left with x plus x cubed, but x cubed can be replaced with an x plus 1. And then we still have our plus a. And x plus x is 0. So we are ending up with just 1 plus a for this entry right here. So we have 1 plus a. And then we have one more. So if you like, you can pause the video and just fill this in if you like. But so this becomes an x squared plus 2x cubed plus x to the 4th plus a. And, well, the 2x cubed, that is 0. X to the 4th we can replace with an x plus x squared. So we have an x squared plus another x squared. That is 0 again, so this is x plus a. This one is 1 plus a, this is x plus a. Just filling in the last few entries right here. Okay, so now we have a filled-in multiplication table. And please work through the other parts of this problem that are on the next page. And you definitely want to use this multiplication table to help you answer some of those questions.